some acids that I need you to know the name of. I'd like you to know the name of these things, just so when you encounter those, that's what some work that you'll be doing. You'll be doing some work with this in your OneNote, basically recognizing these. I know when you go on, let's say 20 years from now, you're working in something and you've got some phosphoric acid. You're going to look that up. You're going to read the label. You're going to Google the thing to make sure that you're doing certain things right or knowing what it looks like. But you're hearing that name beforehand. And a lot of these names are based on some of the polyatomic ions. Polyatomic ions, you mean you might have to recognize those? Yes, that's one reason I made you memorize those, because you've already used them a few times. So here's some acids. Over on this side are some binary acids. Just look at these right now. Binary acids, two things, usually hydrogen bonded to a nonmetal, which is usually one of the halogens. Column 17. All they want to do is gain one electron and they are happy. That's why they're attracting in the first place. Hydrogen is positive, chlorine is negative. Hydrogen positive, bromine negative. Hydrogen positive, iodine is negative. Hydrogen is positive, fluorine is negative. They're bonded together. Throw them in water, they come apart, like we saw hydrogen chloride did. Okay? Hydrochloric acid. Once you mix it with water, then it's hydrochloric acid. Okay? The hydrogen gets surrounded by the negative oxygens of water. The chlorine gets surrounded by the positive hydrogens of water. Okay, so this is going to happen to all of these. The names are hydrochloric acid. Not too tough on these names, but it's not too tough on these. Hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrofluoric acid. Okay, other acids that when you mix it with water, free hydrogens come off. Okay, phosphate group, it was a -3 charge, so I need 3 hydrogens to balance it. Okay, H3PO4 is phosphoric acid. Phosphoric acid. Okay, when I'm naming the acids, oxyacids. Oh, they've got oxygen bonded. Usually 3 things. One thing's usually a nonmetal like phosphorus, nitrogen, sulfur. Carbon, there's an oxygen involved almost all the time, and there's hydrogens, because we need free hydrogens coming off when we mix this with water. Okay? Now remember, the PO4, you had to memorize these, they stay together, the phosphate group. NO2 and NO3, nitrate, okay? SO3, SO4, SO3 is lower, sulfate, CH3COOH, the acetic acid, okay, found in vinegar. That's why I made you know this one. And then this one, CO3. What's the name of the CO3 group? Carbonic acid. Okay. So names. Since this is really the only phosphorus-containing one that you had to deal with, you had to know the name. Phosphate. So phosphoric acid. Okay. The higher number is going to get the ick. The higher number, NO3 is higher than the NO2, it gets the ick. This one is going to get the OUS, the lower number on it at the end. Okay. So nitrous acid, this one's going to be nitrous acid. HNO3 will be nitric acid. Nitric acid, nasty stuff. Okay. SO3 and H2SO3 and H2SO4. You saw me use this one in the lab when we bonded with sugar and we got the black carbon thing growing out of the beaker. Okay, so the higher number of oxygen gets the ick. Okay, and I said the name of that one, sulfuric acid. Sulfuric acid. This one is sulfurous acid. Sulfurous acid. Okay. This one, H2CO3, the carbonate ion, that was really the only one we had, so this is going to be carbonic acid, okay? CHCOOH, okay? Acetyl group, acetic acid is what we looked at there, okay? So, and that's enough with the acids and bases day, and we'll do some more practical stuff with that tomorrow. So thank you very much.